They celebrated what they believed was total victory. The battle echoed with cheers until a deafening roar came from above. A fighter jet streaked across the sky and released a missile. It curved towards its target position. In seconds, the celebration was over. But what determined the path of that missile? That is the science of projectile motion. You're welcome to Dynamic Educational Hub channel. You answer to the very question. In this video, you are going to be learning everything about projectile. Make sure you watch this video to the very end. And without further ado, let's start the class. Let's say we want to project this object along the line. Okay. Now, when this object is thrown, we are expecting that this object should move along this straight line path. On the normal circumstances, according to the Newton's first law of motion, this object should continue along this straight line path. But due to the weight of this object, the weight which acts vertically downward due to the what? Due to the gravitational field, this object will begin to drift away from following a straight line path as shown, and is going to assume this curve. This is a parabolic path. Now let's observe something here. We are going to see that this object is covering both vertical distance and horizontal distance, because this here is y axis and this here is x axis. Now we can vividly see that this object is covering both vertical distance and horizontal distance, is displaced along the y-axis, vertically along the x-axis. So we have two-dimensional motion, 2D motion of this object. Now, what is influencing the path followed by this object? It is the weight of this object, which is caused as a result of what? Gravity. So acceleration due to gravity is involved here. Now, if you observe this object closely, you see that weight is acting vertically downward here. The weight of this object is acting vertically downward and is responsible for this parabolic path. Now, what is responsible for the movement of this object? It is due to the what? To the velocity of the projected object. The velocity. Now, what I'm just trying to explain is I'm explaining projectile. Okay, what is projectile? Projectile is a 2D motion of an object in free space in which the weight of the object is impacting the path followed by the object. Two-dimensional motion of an object in free space in which the weight of the object, which is what? Gravity, is impacting the direction of motion. So that is what is called projectile. Now, in this video, we are going to learn the equation to find the vertical displacement and horizontal displacement, as well as time of flight of this object. Now, let's go back to this diagram here. Let's analyze it properly. So if you are talking about the vertical displacement, something is responsible for it, which is the force that is applied to this object, and the force will result to the movement of this object. So this object is going to have a velocity, an initial velocity. Okay, the initial velocity is responsible for the straight line path that this object ought to follow. So which means we are going to have u. U is the direction that I'm showing you. So we can resolve the u into both vertical component and horizontal component. So let's observe the path followed by this object when it is thrown to a very far distance. This is a parabola. This is a projectile. The same thing happens to the path followed by this object as well. This is also a what? This is a projectile. Now let's find the time of flight, the time taken for this object to reach the maximum height and the maximum vertical displacement of the projectile. It's very simple. Now let's say we project this object, and this object is following this path. This object is going to have an initial velocity. So the initial velocity is responsible for the straight line path motion that this object ought to follow. So we are going to have the angle of the projectile, the angle of projection here, which is theta. So let's have a theta here as shown. Another thing that we are going to have is the initial velocity of the projectile. So this is the initial velocity, u here. Now this u can be resolved into both vertical components and horizontal components. This is vertical components, y axis here, and this is x axis here. Since we are dealing with a vector, vector can be resolved. So we have two-dimensional quantity here. We have 2D motion here. So this u can be resolved into vertical component and horizontal component. So we are going to have this guy here, which is the ux, horizontal component of this initial velocity. Ux is responsible for the horizontal displacement of this object. So we also have uy here, which is the initial velocity along the vertical axis. So this one is responsible for vertical displacement of this object here. This is our angle here. Now, when we project this object, there will be a point at which this object will reach the maximum height. So we are going to have a point here where this object is going to cover a maximum vertical distance. Now the distance between the floor where it is being projected to the highest point reached by the object is called the maximum height. So we can have h max here, which is still the same thing as y max. So this is the maximum vertical displacement. Now this object is going to return here. So this object has completed its flight, its motion. Now the distance between where it is projected here to this point here, so it's called range, which happens to be the maximum horizontal displacement. So we can also call it what? X max. So we can use r to denote it, which is equal to what? X max as well. Another thing that we can observe here is the time taken for this object to move from where it is being projected here to the maximum height. Time taken to reach the maximum height, we can find it. So we call it small letter t. Another thing is the time taken throughout the entire flight, time of flight. Let's start finding our time of flight, maximum height, the range as well. To do that is very simple. We are going to be using equation of motion that we all know before. So let's write out our equation of motion. The first one is v is equals to u plus at. Okay. The next one is v square is equals to u square plus 2as. The next one is s is equals to ut plus 1 over 2at squared. This is sufficient for us to find the equation describing the path followed by a projectile or the time taken, velocity and displacement. Now let's go back to the definition of projectile here. Since we have vectors quantities here, apart from time here, every quantity that is here, they are all vectors. So apart from the time, now this quantity, we are going to have both vertical component of all this quantity and the horizontal component. Part 1. Another thing that we need to notice here is the acceleration here. Let's quickly observe the acceleration using velocity here. Recall that when an object is projected, the weight will act vertically downward. This is due to what? To the gravitational field. Now, as the object is trying to move upward, the weight will try to push the object downward. So there will be what? Uniform deceleration. So we are going to have what? Deceleration. And this deceleration is the opposite of what? Acceleration due to gravity. So we are going to have deceleration due to gravity minus g. When an object is coming down, there is usually an acceleration which is due to the what? To gravity. We call it acceleration due to gravity. That will be what? Plus g, part 1. Now let's write all this for x component and y component. So we are going to start with the first equation. Let's start with this guy. Vx will give us ux. Then someone is asking me plus. No, just calm down. Let's observe something here. In projectile, when an object is projected, the object will have a uniform initial horizontal component of the velocity. So the velocity that is responsible for horizontal displacement will be constant throughout the entire flight until when the object has completed its flight. The initial velocity along the horizontal component, when you resolve it, is going to be constant because the weight is not impacting the initial velocity, because acceleration due to gravity is acting vertically downward. It's not impacting the path followed by the object along the horizontal component. It's only impacting the vertical component. Okay, so Vx will also be Ux because the horizontal component will be constant throughout the entire flight, which implies that there will not be acceleration. So we are not going to have acceleration. Okay, so Ux will also be Vx. So acceleration here is 0. So that is why we are going to have Vx is equals to Ux. So let's have the other one. Okay, the second equation here. The second equation is still the same for Vx. So we are going to have V square x should also be equals to what? U square x. Okay, someone is still asking me why there is no acceleration along the horizontal component. So A is 0. So that one can be verified. If Vx is equals to Ux, it means that V square x should be U square x. Okay, now let's continue again. So which means that the displacement here, Sx, should be equals to what? Uxt. Someone is still asking me why this acceleration is 0 here. Now what we have written here, let's write it for y as well. For y, we are going to have what? Vy is equals to uy plus or minus gt. Someone is asking me, where did I find my g? If we are talking about vertical component, acceleration due to gravity, the weight is impacting the motion. So the acceleration here will be what? Acceleration due to gravity. Okay, that is why we have g. Now someone is also asking me, why are we having plus or minus? We are having it because we are describing the entire motion over here. If you look at it very well, when this object is projected, it is moving upward. It got to a point when the speed becomes 0. The velocity becomes 0. It starts coming down, moving downward. So when it moves upward, we have uniform deceleration, negative acceleration, minus g. When it is moving downward, we have uniform acceleration, plus g. It depends on which side you are considering. That is what led to plus or minus. So if you are considering the vertical is moving upward, you pick what? Minus gt. It's moving downward, you pick what? Plus gt. All right, we are good to go. So we also have v y square here should give us what? U y square plus or minus, we have a here, plus or minus what? 2 gsy. Okay, finally we are going to have sy, displacement along the vertical component will give us what? Uyt plus or minus 1/2 gt square. Hope you are following me. Okay, so we can see this. All right. Another thing that we need to observe here is, let's resolve our initial velocity. To resolve it, let's come over here. So we have u, right? If you want to resolve u into horizontal component, so we have ux will give us what? Horizontal component is cos. So you have u cos theta. Uy, vertical component is sine, u sine theta. If you don't know how to resolve vector into their various components, horizontal and vertical component, you can check out my mechanics video. Okay, resolution of force, resolution of vector. I have it on this playlist, in mechanics playlist. You can check it out. All right, let's continue here. So we have gotten the equation of motion for this projectile, which is having a parabolic path. All right, let's go. The first thing here is we want to calculate the time taken to reach the maximum height. So let's call that time small letter t. Time taken to reach what? The maximum height. Let's observe the maximum height. If you observe the maximum height here, you discover that when this object reach a maximum height, the speed will be 0. Isn't it? Maximum height, the speed will be 0. At maximum height, the speed will be 0. Another thing that we need to consider here is we want to consider the vertical component, vertical aspect of this. We want to consider the first half of this motion. Let's consider the first half of the motion. Now, which equation are we going to use that is having time? We are going to use this one. Since we are interested in the vertical component here, time taken to reach the maximum vertical displacement, maximum height. Okay, at maximum height here, velocity is what? Velocity is 0. So we want to calculate the time. Okay, now let's go. So which means that the final velocity here will be 0. Let's pick the first equation here. So we are going to have what? Is 0, which is going to be our Vy at that moment. Final velocity. What is Uy here? Uy is what? U sine theta. I'm picking this first one. Since we are considering the first part, so we can have minus. It's going upward, minus gt here. The time taken to reach that height. Okay. So which means that gt is equals to u sine theta. Isn't it? Okay. T here will be what? U sine theta over g. U sine theta over d. So this is time taken to reach the maximum height. You can see that it's very simple. We are still using equation of motion. Now let's calculate the time of the flight. The entire time taken during this entire flight is very simple. We have observed the first part. So the time taken for this object to move from here to here is still the same thing as the time taken for this object to move from here to here. So what we just need to do is time of flight, which is capital letter T, will be 2 times this. 2 multiplied by this will give us 2u sine theta over g. So this is the time of flight. So let's go ahead and find the maximum height. To find the maximum height here, you recall that when this object is projected, when it's reached the maximum height, the final vertical component of the velocity is 0. It's not the same. It's changing, it's reducing. When it gets to this point, it becomes 0. That is why we have Vy is equals to 0. Okay. Now we can also use the time taken to reach this maximum height, which is t, small letter t, that we have calculated previously, that we have calculated the other time. Now we just pick one out of this equation and substitute the value. We make sure we pick the one that is having displacement. Okay. If you use this one, you get an answer. If you use this one or this one, you still get the same answer. So let's pick this one. Picking this one here, we know that Vy is 0, so we are going to have E0 is equals to Uy square. Now, since we are considering the first part, so acceleration due to gravity will be minus. We have deceleration, uniform deceleration minus 2g. Now, this is maximum height. It's supposed to be what? 2g sx. That sx is h. So let's just write it s 2GSY. That SY is H, the maximum height. So let's have it this way. Now let's rearrange this. We are going to have 2GSY is equals to UY square. Okay. Now SY is the maximum height. So we have 2GH is equals to UY square. Now what is UY? UY is what? U sine theta. So we have 2GH is equals to U sine theta square. So let's make H solve the formula. Making H solve the formula, you're going to have H is equals to, you divide both sides by 2G. So U sine theta multiplied by U sine theta, you have U square sine square theta. Not sine square theta, theta square. Okay, it's sine square theta divided by what? 2G. Now this is the formula to find the maximum height. Now you see the equation that we have used. What if we decide to use the other one? We decide to use S is equals to UT plus half AT square. If we are using it, we are still going to get the same thing. Okay, we are still going to get what? The same thing. If we are using that, we consider this as well. Our U will be what? Our U. This one will be the initial velocity if we want to use that formula. This guy here will now becomes what? The initial velocity. So the initial velocity will be 0 at this maximum height here, because it's going to come down, it's going to accelerate. So you now have what? Your H, which is SY, is equals to, this part is already 0. Okay, that's UT. You now have, since you are considering this part, it is positive. So you have 1 over 2 GT square. Okay. Now this T here is time taken from this object to move from here to here, which is still the same thing as time taken to reach the maximum height. Okay. So we have calculated that. Just go ahead and put that inside this expression. We are going to get the same answer. So which implies that H is equals to 1 over 2 G multiplied by, what is time taken to reach maximum height? That is U sine theta over G. You now have U sine theta over G all square. So our H here will now be equals to 1 over 2 multiplied by G here. When you expand this guy, you get multiplied by U square sine square theta over G square. Okay, you expand this, U sine theta multiplied by U sine theta, you get this. G multiplied by G, you get this. Now 1G here, we cancel this 1G out of here. So finally, what will now be this expression? Our H is equals to what? U square sine square theta over 2G. You see that we still get the same answer. This is how to find the maximum height. You can use this approach, you can use this approach. We see that we still get the same answer. Over to the range. How do we find the range? Very quickly, it's very simple. To find the range here, we see that range is the maximum horizontal displacement. Okay, so we are going to be using everything that pertains to X. All right, out of all this formula, we can use this. Now just use this, don't stress yourself, use this. Okay, now to find the maximum horizontal displacement, the time taken to reach the maximum horizontal displacement is the time of flight. So the time in this formula will be what? Time of flight. Since we are finding the horizontal displacement, we are going to have Sx is equals to Ux multiplied by T. The T here is the time of flight, capital letter T. So let's go ahead and substitute the value of this guy. So Sx is the range here, R. Ux is what? U cos theta. What is time of flight? Here, time of flight is what? You open bracket, U sine, you have 2 U sine theta over G here. So you have this. When you expand this, R will be what? U square multiply by what? 2 sine theta cos theta. You can also bring your 2 outside here over G here. Now let's do something. You recall that sine A plus B coming from trigonometry identity is equals to sine A cos B plus sine B cos A. So instead of having theta here, we can have sine 2 theta will be the same thing as what? Sine open bracket theta plus theta. Theta plus theta will be the same thing as 2 theta. When you expand this guy here, you have sine theta cos theta plus sine theta cos theta. At the end of the day, you have sine theta cos theta plus sine theta cos theta. You have 2 sine theta cos theta. So where you see 2 sine theta cos theta, you can easily put sine 2 theta here. So which means this one becomes what? Sine 2 theta. So the range here now be u squared sine 2 theta over G. So this is a formula to find the maximum horizontal displacement. Now, if you want to find the horizontal displacement at any time, you use this expression. For the maximum one, you use this expression. That's how to find time of flight, the range, and the likes. All right, thank you for watching this video. See you in the next video. Bye for now.